Thank you, thank you. Yeah, my name is Heng. My topic is from virtual prototyping to smart construction. Basically, I'm going to take you through a personal journey of last 20 years of my research. I came to Hong Kong in 1997. By the way, I'm only slightly over 25 years old. Okay. I started my school very early. Oh, Professor Jacob Chung is younger than me. He's 24. Yeah, well, when I arrived in Hong Kong, obviously I need to find some research money. So I went to talk to the industry. I talked to a few contractors, asking them, what is your problem? How can I offer my service? And then many of them told me a phenomenon. They say, in my project, we got lots of rework. The rework caused by design and construction errors. Can you do something to solve those problems? So that's how I started. That time, there's no BIM. We used a software from aerospace engineering, and then we invented this term called try before you build. Basically, it's to digitally mock up the construction process, see how we did it. One of the projects is Wine Island East. We actually did the model in 2000. Then we actually digitally mock up the construction process to see this can be built in computer first, and then during the process to eliminate all the possible construction sequencing error. And actually, it went very well. Because I got too many slides, I have to go through very fast. I got 50 slides, okay? Then we published papers, and then we went so far. We even actually started a company with a local contractor called VHSoft, and we started to develop a software called IntelliCAD. It didn't work. We lost lots of money. But some other products are still actually there. We did some other things, like process optimization, how to shorten the duration from 6 days to 4 days, and how to resolve complex construction problems. In this case, is how to design appropriate platform. It's not big, not small, just enough to host all the equipment and material and the storage and so on. Yeah, the conclusion we had that time is, we call it a virtual prototyping or digital construction really helped because it provides you a way to try before you build. Okay. And then with the help of Housing Authority and the leadership of EDA, we had a lot of opportunity to sharpen our skills. We did lots of performance analysis, wind analysis, sonar shading analysis. It goes on. Thank you, EDA. And then, for example, you can do a model from a very simple residential building and quickly build a model. That time, it's actually MSc students' work. And then from there, you can do temperature analysis, humidity analysis, and all that. There's no limit. You can almost do any simulation in the 3D environment. You can do sun shading, humidity, noise, and all that. This is fantastic. I was so impressed by this because, if we use analogy, you see how important this skill is. I bought a flat. I bought a flat a long time ago. I spent $6 million that time. But can you believe it? The contract document I signed, along with a lot of standard clause which I didn't even read in lots of legal terms. But the only information about the flat I had was this 2D drawing that I shown here is hand drawn. Okay, that time I didn't actually find it surprising. I paid $6 million. That's our industry. But if you go to a supermarket in a shop to buy microwave, what do you get? You probably pay $2,000, but you get lots of documentation, right? It tells you what you can do, what you can't do with it. So by contrast, you can see our industry is lagging behind the manufacturing industry miles way. So I personally believe, this 3D simulation performance analysis has a long way to go. It affects the industry, and it should affect our education as well, because the way we teach our students is still old-fashioned. Okay, then it came to 2009. That time, everyone was talking about the BIM. Then I thought I should do something else. I then moved on to smart construction. That's from 2009 and now. Then the problem I'm facing is, I think in that chunk of project cost, the management cost is too high, way too high. Because if we compare our industry with the manufacturing industry, we got a very big margin of management cost. We should try something to reduce it. So that's how it started. This is the situation. You got lots of managers, not enough soldiers. So we started working on other technology. And the purpose is trying to replace human eyes and human simulation with IoT intelligence. That's the first project we did. We tried to put sensors on the helmet on the workers. Sorry, I don't have time. I have to skip it. But the idea is trying to automatically collect information from site movement and do management decision. It has pros and cons. The project didn't go very well because all the workers don't like to have some sort of sensor on the helmet. They think in the helmet, the sensors has a battery. It might cause some sort of brain cancer. 2 is a privacy issue and all that. So we gave up. Okay, can't argue with them. Then we thought, if we can't put it on the helmet, we'll put it in shoes. The idea is simple, is same. We put the sensors and battery in the shoes, do exactly the same. We can even do the reverse dynamic to estimate the posture. We can do, we can even put a self-charging battery into it. Good topic for writing papers, right? But this thing doesn't even work because even in the insole, it's not stable enough. After a few months, the material is not durable. It doesn't work anymore. Also, it's very stinky. People would not wear it. So we now change it to different technology. We think, okay, shoes no good. Maybe computer vision is better. So what we're trying to do is we're trying to use surveillance camera and the artificial intelligence to replace the human eyes and the brain, doing exactly the same thing. We can do safety management, we can do productive estimation, we probably can do many other things. But it's a good trial. But so far we think to some extent, if you can see them, if the camera can see them, and then using this deep learning technology, as some other professors say the same thing, you can recognize what they are doing. You can do a very accurate assessment of the productivity, right? And in this case, it's rebar workers. If the site allows a video camera, then the data can be translated to a computer, and all the things can be done automatically. I think with the better equipment, better hardware, this technology has a long way to go. Imagine, if you turn this on, the site agent can just go for coffees and don't need to watch the site anymore, right? Because everything can be recorded and analyzed. So I think this is probably something that will be a very nice continuation of the modeling exercise, because that will actually collect the information and feed back to the model and to do the comparison, see if the project progress is right on time, and then safety and all that we're in a good range. Okay. Sometimes the video camera cannot see every corner, because you got lots of area. Either the vision's no good, or you just don't have enough camera. So we think maybe you should need some other technology to supplement it. So we think, you know, if you cannot see them, maybe you can track the tools they are using, you know. For all the trades, no matter it's rebar or carpentry, anything, the workers cannot do it with bare hands. They have to use some tools. Either it's handheld tools or mechanical tool, electrical tools. They have to use tools, right? So if we can track the tools, then we can then go back to estimate what they have done. So we use the IMU, is a inertial motion unit, is a sensor to track the tools. The idea is, for example, if you track the tools and know the movement of the tools, you can estimate what they have been done, right? For example, here is a concrete vibrator. If you know how the vibrator is actually moved, then you can estimate what has been done, whether they have cut corners and all that, right? So then we track the tools, then we build a network around the tools. Then what's happening is, with all this network, we can build a sequence in how these trades are dependent. Okay, this has a lot of significance. For example, if there's a quality issue, for example, in the Shazhongxing, something happened, right? We trace the tools, then we go back and see who has done it, who should be responsible for it, right? So I think, again, this technology has lots of potential. And this is something probably the industry should take on and develop it further. So all these hidden projects and projects that cannot be supervised properly, they all allowed to use this tool. We are going further. Lots of research, lots of pressure, because Jack knows we always have to chase money and publish, right? We're going on. We think, after that, what should be done? Because, at the moment, we think the workers, construction workers, are suffering, because we did some interview. We found a lot of local workers after a whole day work. For example, carpentry. They can't even hold a cup of tea because their muscles are badly fatigued. So we are now studying two things. We're trying to build artificial muscles, just like a waistband, to help the workers to reduce the physical intensity. The project is too fancy for you to probably to bother to understand it. It's about the material, about the electricity, about the sensors. It's a good topic. And for example, this is a functional material. The idea is some materials, if you put it through the electricity, then it will expand. It acts like muscle, right? And then you can use different materials, and with a right amount of electricity, then it will act like a muscle. So thinking if you have those muscles, those artificial muscles, then you don't need so much your own intensity when you do the harmony. This is the idea. We're trying to get some funds. In case any of you have some spare money, let me know. Okay, I need a lot of money. And the other thing is robotics. I think our industry is learning from manufacturing industry. If you look at the manufacturing industry, what's happening there is that they have machines talking to machines without human intervention. They can get things done without someone to tell them to do, right? I think robotics has a long way to go in our field. Now we are slowly, gradually moving into this area. We're trying to understand the mechanisms of robotics. So we start to build robots, and the robots has two parts. The hardware, you have to have some sort of hands and the movement equipment, and then the control mechanism, that's software. So hardware, we can't do anything, we have to buy. But we're playing with the software. Things like picking up little nails and screws left on the side or something, But this is a very academic exercise. But the purpose is to understand the principles or the maxims of the controlling software. Papers. I've gone too far. Someone gave me an idea, said, these 50 slides cannot be covered in 20 minutes, but I did it in 15 minutes. Okay, I've gone too far. I'm sorry. Okay, yeah. My personal view is that in our field, in terms of research, we need to understand a lot more about how humans can work with robots in the future. So you either have a tow crane driver sitting in the office and to remotely operate tow crane, or you have some ability to control an arm, a robotic arm, and the arm will do the things for you. But we enable to do it. We have to understand, the mechanisms behind them, where these machines can be applied in our field. And then, of course, Eda also mentioned facility management is lagging behind. We have models, we have all these beautiful buildings, but how can these models and the buildings can talk to each other to form some sort of digital twins that they can support each other, especially to optimize the FM in terms of saving energy and the cost and all that. Of course, if aggregate all the buildings or infrastructure together, it will be a smarter city. So all these issues are very interesting and grand. So we hope we'll be able to partake and participate in all these activities. I don't think I have a lot more to say now. I still got 3 minutes, Eda. Okay, so I probably just finish a little bit earlier so that the most important part of the show will come. Eda will come to host the Q&A session. Thank you so much. Thank you.